B heap. So first of all, what is the B heap? B heap it is a heap data structure that takes the form of a binary tree. Binary heap are common way of implementing priority key. So what is the motivation for the creating the heap? In the in the tree structure, if we want to traverse in a vertical way, then we take maximum time. For that, if we want to search the node in a vertical way, then we have to traverse to the level by level. Then we create a heap. In heap, there are a few properties that we must follow. That first property is it is a complete tree. That means all levels are completely filled except possible the last level, and also all keys in the last level as left as possible. We have to keep. Let's see the example as shown in the figure. There is a heap. There is a tree structure in which all the level, first zero level, then the second level and the third level. All the levels are filled. Then after next level fill. In the last level, as the left element, we first fill the left element, then left to right. Okay. And the second property is binary. A binary heap is either a mean heap or a max heap. So what is the mean heap? First of all, mean heap, the key value of the root must be the smallest among all the keys in the heap. And the as well as the max heap, the key value of the root must be the biggest among all the keys. Let's see the example. So the first one is the mean heap. As you can see, the root of the heap is 6. It's the smallest. Then we go to the left side, there is a 7, and their child 7 and 12. 7 is the smallest among its child, and the 12 is smallest among its child. As well as we can see the mean max heap. 17 is the maximum number in the heap. As we go down, we can see that the all the parents value is greater than its child. uh, then how we can represent our binary heap? So we can represent a binary heap as an array, and the root element of the heap will be at the array of 0. And all the if in the ith node of the heap, we can say that it's in the array, it is in the I by 2, and its left child in area of 2 cross I, and its right child in area of 2 cross I plus 1. In the example, we can say that the 0th node 1, then its child 3 and 6, then its 3's child 5 and 9, then 6 child 8. Then what operation we can do in heap binary? First of all, insert function. So there is the algorithm we must follow. So according to the algorithm, firstly add the element to the bottom level of the heap at the leftmost, then compare new element with its parents. If they are I the correct order, then we can't we don't go further. If not, then swap them and return to the previous step. Let's see the example. In this example here, we want to add 15 to the max heap. This is a max heap. So the parent value is greater than its child. So we take this property. We add 15 here x. Then we compare child and parents node. 8 is parents, so we swap the node. Then second, Then again we check the property that the parent's value is greater than its child, but here it violates. Then again we swap. Then 15 goes to the root of the heap. Then it's it it uh, it perform very well, and it is following all the properties of the binary heap. Then we set the extract, how we can delete the root from the heap. So firstly, there is a algorithm. The first step is firstly replace the root of the heap with the last element on the last level. Compare the new root with its children. If they are in the correct order, then stop. If not, swap them with one of its child, smaller in min heap and larger in max heap. So we want to remove the root of the heap, which is 11. So we replace it by the last node, which is 4. So we replace it. Then for the binary heap, binary heap must follow its property, and this is a max heap. So max heap root must be the highest value in among the all nodes. So after this, we perform down heapify. So we compare it by its children. So then we swap it by 8, which is the largest value among its child. Here 5 and 8, but we replace it by 8 because it is the highest value among its children. Then the search operation, it's take order of n and decrease or increase the key. In this operation involves finding the node with the given value, changing the value, and then down heapify or up heapify to maintain the heap property. So decrease key. So there is an example. Here is an example. We do change the 5.6 to 0.5. So we change it, but we have to follow the property. So for the this is a mean heap. So we have to perform the up heapify. So we compare it by its parents. So it is greater than. So we have to swap. After that, 0.5 become the parents of 3.9 and 3.3. Then after this, then we again compare with 1.6, which is the greater than, so that we have to swap it with the root of the heap. Then what is the final result is this. So delete operation. What is the delete? For the delete operation, there is an algorithm which is says that find the index I of the element we want to delete. Swap it with the last element, down heap, up heap to maintain the heap property according to the. So here is a time complexity of all the operations: space, search, insert, delete, average, worst case, order of n. For the search, order of n. For insert, order of 1, order of log n. Delete, order of log n, order of log n. So where we can use this binary heap in the heap sort, it use binary heap to sort an array in order of n log n time. In the priority queue, to perform the priority queue, it can be implemented using binary because it support insert, delete, decrease key function in order of log n. Hence, all graph algorithm like prims, minimum, spanning tree also use primary priority key. Hence, the priority key can be very fast and very supportable very fast with the binary heap. So in all the graph algorithm, with the binary heap, time complexity of the graph algorithm will decrease. Then the many problem can be efficiently solved using the heap. Example, case largest element in a array, sort and almost sorted array.